All right, so I've laid out your work for the week. We'll be covering a new lesson every day. You need to read through the first section on systems of linear equations and inequalities on Monday, as well as the second section. I will work examples from each section. That way you can see how they're worked and what I'm expecting you to know coming through. This should be a lot of review, but basically the idea is we have a system of equations. This is the second session's example. We have a system of equations that we need to solve for, and in order to do that we need to either make the x's match each other with the same coefficient or the y's match each other with the same coefficient. So I'm going to go ahead and choose the x's. So I'm going to multiply this one all the way, every piece of it, I'm going to multiply by 5. And this one, every piece of it, I'm going to multiply by 3. That will give me 15x plus 20y equaling 30. And this one will become 15x minus 21y equaling 28. Or 28, 42. So here, now what you need to imagine with this is, I want to talk about why we're allowed to add or subtract equations from each other. Because really, this equation represents the fact that we have a set of scales, and on one side of the scale, we have 15x plus 20, and on the other side of the scale, we have 30. And if you put those on the scale stays exactly balanced because they are the same weight, or they're the same value, the exact same value. So since they're on a scale and the scale is even, and this equation also represents another equation where the scales are even, if the scales are even, holding the same weight on both sides, and you took and combined the scales should still stay the same weight. So let's imagine we had scales that on this side was 10 and on this side was 10. Those will stay even. And we have another set of scales where it's 20 and 20. If I combine the 20 and the 10 on one scale and have 30 on both sides, 30 and 30, the scales still stay even. Likewise, if I take 10 away from 20 and I take this 10 away from this 20, I can add or subtract them and they'll all stay even because both sides of the scale are always even. That's why when I multiply this side of the scale and that side of the scale. This side of the scale and that side of the scale. Everything, if it's on a scale, everything's got to be multiplied. Just to make sure that we have this down all the way I want you to make sure you understand it is if I had a box and 2 balls being the same thing as 10, and I double the 10 and I make that 20, then I'm going to need 2 boxes. And not just 2 balls. I'm going to need 4 balls. I have to double every piece of that. So I have to double the box and the balls. Just like this. I have the 3x's and 4y. If I want to take 5 times the 3x's, I better take 5 times the 4y's as well. Because the x's are like the boxes and the y's are like the balls. And you got to make sure that both sides stay even. So when you have the picture of the equation and the scales in your head and you think about it this way, a lot of other stuff will fall together the way it's supposed to. If you don't understand that, then we need to go over it again. So we have 2 equations which represent a balanced scale for both of them. And what we're going to do is we're going to subtract this one from this one. So we're going to take away this number from here. We're going to take away this number from here. We're going to take away this number from here. So if I take away, basically I'm going to go through and subtract every one of these. Take away each piece. So this will give me 0x plus 41y equaling negative 12. That means that y, if you punch it in your calculator, which I hate, so please don't, just don't do it. I want your answer looking like this. And the book might say otherwise, but since I'm grading your test, you get to do what I say. So I want it left as a fraction because fractions rule. So that's how I would leave that. Then if we were to graph this, it's just, I'm going to give you another example after. I'm going to work example 2. which is they want me to solve the system and graph. The system that they have there is 5x plus 2y equals 10, and 5x plus 2y equals 20. Now, if I'm going to solve this, right, what do I get? I get, well, my coefficients already match. So I say 5x minus 5x, well, that's 0x. 2y minus 2y is 0y, equaling negative 10. So does it make sense that 0 equals negative 10? This does not make sense. No sense. 0 does not equal negative 10. But we came up with something where it says it equaled. Why does it say that? It says that because the lines are parallel. So, for fun, let's go ahead and convert this first one into slope-intercept form. We would get 2y equals negative 5x plus 10. That means y equals negative 5/2 x plus 10. And this one, we're going to get the same thing. We would get, 2y equals negative 5x plus 20. So y equals, this should have been 5, because 10 divided by 2 is 5. Okay, so this one should be negative 5/2 x plus 10. So here, the slopes are identical, but the y-intercepts are different. So what does that look like? So here the y-intercept is 5. 1, 2, 3, 4, 5. Here the y-intercept is 10. 6, 7, 8, 9, 10. But both of them are going to do the same thing. They're going to go back 5 and down 2. So this one's going to go back 5 and down 2. Now when we draw these lines, ooh, it's horrible. They're parallel. And the solution of one of these problems is supposed to represent where they touch. These two lines don't ever touch, and they will never touch because they're the same slope. Since they will never touch, there is no solution. There's no point that I can plug into one and it works for the other one. Those are called inconsistent, and it's important you know the word inconsistent. Inconsistent means they never touch. So just for fun, let's take a look at, I'm going to do another example of x minus y equaling negative 11, and also 7x plus 4y equaling negative 22. Now on this one, you're going to, we can just multiply, let's multiply the top one by 4 for fun. So if I multiply the top one by 4, remember I'm multiplying every piece on the scale by 4. So I'm going to get 4x minus 4y equaling negative 44. Rather than do it up there, I just went ahead and brought it down. So this is really right here. Now these equations are the same. I'm going to go ahead and add them together, because remember we talked about the scales. I can add the things on the scales together. I can take away the things on the scales. It will all work. So when I add this, I get 11x equals negative 66. That means x equals negative 6. So if I went ahead and put this in to this equation, I would get negative 6 minus y equals negative 11. Minus y, then if I add 6 to both sides, be negative 5. So y must equal 5. So my point here, my xy point would be negative 6, 5. What this represents, I can put this point into this equation and it's true. I can put this point into this equation and my answer is true. If I put this in here, what I would end up with is negative 22 equals negative 22. That's true. If I put this in here, I'm going to end up with negative 11 equals negative 11. That's true. I can take this one point, put it into both equations. Both equations are true. That's how we define a solution. Now that we have that, I want to go back and I want to plot this line. I want to go ahead and draw them just so you can see how that point matches up with where they cross. Okay, so if I plot this one, I'm going to go ahead and change it into slope-intercept. Actually, I'll just go ahead and do this. 0, x, y. If I put a 0 in for my x, y is 11. If I put a 0 in for my y, x is negative 11. That's pretty easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to look something like this. Now I'm going to do the same thing here. I'm going to go ahead and put a 0 in my x and my y. Put a 0 in for my x. 0, that would give me y would equal a negative 22 fourths, which is like 5.5. Okay, so that would be 0, 5.5, 1, 2, 3, 4, 5 and a half. So there's the first point. And if I put a 0 in for my y, then I get negative 22 sevenths, which is about a little bit more than 3. So if I went ahead and made this line, what we're saying here, oh my gosh, I must have these way off. This should really be, this point here should match that, but apparently my drawing is horrendous because it doesn't match. But in an ideal world, I would label this negative 6, 5, because that's where they're actually cross. All right, so that's how you do all of 4.2, or that section there, the chapter 4, section 2. You should be able to complete the homework on that. You will read all of 4.1, then do all the review questions on 4.2. That's Q1 through Q10 all, and then 1 through 51 odds.